Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. In this lecture we will continue with the questions. Right? In the previous lecture we studied about criteria for similarity of triangles and then we did some of the questions, right? So let's continue with the questions here. If CD and GH are respectively the bisectors of angle ACB and angle EGF, such that D and H lie on sides AB and FE of triangle ABC and triangle EFG. So there is a triangle ABC and triangle EFG. Angle bisector of angle ACB. So we are talking about this angle here, and this is the angular bisector and it meets AB at D. Similarly, angular bisector of angle G meets EF at H. Right, so this is the angular bisector here and these two angles are also equal. Now, if triangle ABC is similar to triangle FEG, then show that this first one and second one, and there is this third one. Okay, so if triangle ABC is similar to triangle FEG, we need to show these three relations. So first thing, what is given? Triangle ABC is similar to triangle FEG. And what does it mean for us? That angle A is equal to angle F, angle B is equal to angle E, angle C is equal to angle G. It means that this angle here is equal to this angle, right? So if it is alpha, this is also alpha. Why do I write the names of these angles as alpha, beta? So that it is easy for you to visualize and you do not get confused that angle A is equal to angle E here, because it is not. Angle B is equal to angle E, so let me name it beta. So this angle here is beta, and the third angle, that is angle C, is equal to angle G. If, let me see, if angle C is equal to angle G, what will be half of angle C? Half of angle C will be equal to half of angle G. So if half of angle C is theta, then half of angle G will also be theta, right? So this part is also theta, this part is also theta, right? Now that I have named these, it is easier for me to look at these and visualize. Also, these two triangles are similar, that means the ratio of their sides is equal. AB by FE, BC by EG is equal to AC by FG. So these things are given, right? Now the first thing that we need to prove is CD by GH is equal to AC by FG. So we need to involve this angular bisector. Now that I know this ratio is equal, let me consider these two triangles, this one and this one. Why I am considering these two triangles? Because I know that I need CD and GH, CD and GH, I need AC and FG, AC and FG. Okay. Also, the two angles alpha theta are equal. Okay. So in triangle ACD and triangle FGH, we can see that two angles are equal. So by angle similarity criterion, these two triangles, that is triangle ACD is similar to triangle FGH, and now I can talk about that ratio. CD by GH is equal to AC by FG. That is what I had to prove, right? And proved. And here, if you want to write the reason for angle similarity, you can mention the angles also. I just showed you by alpha and theta, that is why I didn't mention it. Otherwise you can say angle A is equal to angle F here, right? Angle A is equal to angle F. And what was the other angle? Angle ACD is equal to angle FGH. That is what you can say here. And then by angle similarity, you can prove that these two triangles are similar. Hence, by the definition of similarity, we can say the corresponding sides are proportional. So what was the second part? Triangle DCB is similar to HGE. So let us look at these two triangles. In triangle DCE and triangle HGE, right? Which one is DCB? We are looking for triangle DCB and HGE. So this is the triangle DCB and this triangle is HGE. As it is pretty evident that beta, theta, theta. So two angles I have already shown as equal. Because of this diagram, you can already see that two angles are equal. So by angle similarity, you can directly say that these two triangles are similar. Otherwise, as I mentioned earlier, you can show that angle DBC is equal to angle HEG, because I have taken these two angles as angle beta, right? And what is the other angle? Angle BCD here. Angle BCD is equal to angle EGH. These angles are equal to angle theta, right? So two angles are equal. So by angle similarity criterion, I can say that triangle DCB is similar to triangle HGE. So this was a simple application of similarity here. Now look at this one, DCA HGF. So I have already shown you that DCA and FGH are similar. When I proved the first part, I have already shown that DCA, that is this triangle, is similar to HGF, that is this triangle. Okay, so already proved in part 1. Otherwise, you can show the two angles as equal. Which angles? In ADC or DCA, you have alpha and theta. In HGF, you again have alpha and theta. So two of the angles are equal. Hence, the third angle is also equal. So by angle similarity criterion, you can say that these two triangles are similar. Now in this figure, E is a point on side CB produced of an isosceles triangle ABC with AB equal to AC. So the first thing is given that AB is equal to AC. So I'll take this angle as alpha. So this angle will also be alpha. And the statement I'll make here is that AB is equal to AC. Hence, base angles, angle B and angle C are equal, because in an isosceles triangle the angles opposite to equal sides are equal. Okay, and if AD is perpendicular to BC and EF is perpendicular to AC, then prove that triangle ABD and ECF are similar. So in triangle ABD and triangle ECF, look at triangle ABD. In triangle ABD, you have got two angles, alpha and this angle 90 degrees, right? These two angles I know. Why do I know alpha? Because I can compare this alpha with this angle here, angle C. In triangle ECF also, we have got one angle as angle 90, one angle equal to 90 degrees and other angle, that is angle C, equal to alpha. So what I can say here is that in triangle ABD, angle B is equal to, in triangle ECF, angle C, because both equal to alpha, which I have taken here, right? Alpha is not mentioned in the question, but I have taken angle B as alpha. So angle C also became alpha because of the properties of isosceles triangle. Now angle B is equal to angle C, and in triangle ABD, angle ADB is 90 degrees, and in triangle ECF, angle EFC is 90 degrees. So both are equal and equal to 90 degrees. Now because of angle similarity criterion, we can say triangle ABD is similar to triangle ECF. So this is how you will prove it. Sides AB and BC and median AD of triangle ABC are respectively proportional to the sides PQ, QR and median PM of triangle PQR. So what is given here is AB, BC, AD of triangle ABC are respectively proportional to PQ, QR and median PM of this triangle. Right, so we have got two triangles PQR and ABC, and it is given that AB by PQ is equal to BC by QR, AD by PM. So the medians. Okay. Now we need to show that triangle ABC is similar to triangle PQR. To show triangle ABC is similar to triangle PQR. Now, for a moment, look for these two triangles. AB and PQ, ratio of AB and PQ is equal to ratio of AD and PM. Okay. If I can say that ratio of BD and QM is also equal, then these two triangles will become similar. And if these two triangles become similar, these two angles will be equal. Right, and hence we will be able to prove that triangle ABC is similar to PQR very easily. Now BD by QM, ratio of BD by QM is nothing but twice of BD by twice of QM. So I can multiply and divide it by 2. Now what is twice of BD? Twice of BD is BC, because AD is median, so BD is equal to DC. Right, similarly QM is equal to MR. Hence, twice of QM is nothing but QR. So, BD by QM is equal to BC by QR. So, I can put it here also. BD by QM. Because it is equal to this. So, it is equal to all of these. Now, to show these triangles as similar triangles, I am considering triangles PQM and triangle ABD first. In triangle PQM and ABD, PQ by AB is equal to QM by BD is equal to PM by AD. Right? Why do I say that? AB by PQ, PQ by AB. So the reciprocal of this ratio is equal to reciprocal of this ratio. So QM by BD, yes. And what is PM by AD? It is reciprocal of this. So yes, it is true. Hence, I can say triangle PQM is similar to triangle ABD, and if these are similar, angle Q will be equal to angle B. So this angle here, if this is alpha, this is also alpha. Right? Now see, PQ by AB is equal to QR by BC, and the angle included between them are also equal. Hence, these two triangles are similar. So I can say PQ by AB is equal to QR by BC, this is given, right? And angle Q is equal to angle B. Hence I can say triangle PQR is similar to triangle ABC. Right? PQ and QR and angle included between them. If you do not understand this relation, what you can do is you can bring this QR here. PQ by QR is equal to AB by BC. Now you can see PQ QR and angle between them, that is Q or angle alpha. Similarly AB, BC and angle between them alpha. Hence I can say PQR is similar to ABC, or triangle ABC is similar to triangle PQR. Okay. Now D is a point on the side BC of triangle ABC. Let us say this is triangle BC, and D is some point on side BC of triangle ABC, such that angle ADC, that is this angle, is equal to angle BAC, that is this angle, right? So if this is alpha, this complete angle is alpha. Show that CA square is equal to CB into CD. Okay, so I can break CA square into CA into CA, and it should be equal to CB into CD. So CA by CB should be equal to CD by CA. Okay, let me consider these two triangles. Triangle CDA. Why I am considering this triangle? Because I'll make it similar to the bigger one, triangle, this bigger triangle. Let me check the correspondence, then I'll tell you the name also. Because one angle here is alpha and one angle, that is angle A, is alpha. Second angle is this, which is common to both of these triangles, this smaller one and the bigger one. So by angle similarity, these are similar triangles, and then I can show CA by CB, CD by CA. Now I am considering CDA and bigger triangle CAD. Okay, considering these two triangles, I can say angle C is equal to angle C, common in both the triangles. What is the other angle that is equal? Angle CDA in smaller triangle is equal to angle CAB in bigger triangle. I have named both of them as alpha for your convenience. Now two angles are equal, so by angle similarity criterion, triangle CDA is similar to triangle CAB. Okay, so CA by CB, CA by CB is equal to CD by CA, CD by CA. Yes. Why? Because ratio of corresponding sides of similar triangles. Okay, so this relationship is proved, because if this is true, then if I cross multiply them, CA square will be equal to CB into CD. Okay, let's look at next question. Sides AB and AC and median AD of triangle ABC. So there is triangle ABC, and this is median AD. Median means that it bisects side BC, and there is triangle PQR. This looks like a similar question to question 12 or the previous question. I cannot name the question number, so let's avoid it. Now in this question, in triangle PQR, PM is the median, so QM will be equal to MR. This much is given. I need to show that ABC is similar to PQR and ratios AB, AC, AD by PQ, PR and PM, these ratios are equal. This is given. Okay, so AB by PQ, AC by PR, and the ratio of medians is given. Okay, so I cannot proceed like the question I just did. We cannot proceed like that, right? So we need to devise some other method. Whenever you get medians of a triangle, what you can do is you can extend that median equal to its own length. So if this is, let us say, of certain length AD, I am extending this equal to AD here up to this point, let us say E. Now if I join this and complete this quadrilateral, what kind of quadrilateral will it be? You can look at the diagonals and think it yourself. because this in this quadrilateral diagonals are being bisected at D, so this quadrilateral is a parallelogram. So I can say ACEB is a parallelogram. First you need to mention that extend AD up to E such that AD or DA is equal to DE. Right, now it has become a parallelogram because diagonals bisect each other. Whenever you are stuck in a question where medians are involved, you can do this construction and this might give you a clarity in that question. Similarly, if you extend PM and then join R with this point and Q with this point N such that this segment here is equal to this segment. Now PQNR is also a parallelogram, right? PQNR is also a parallelogram because of the same reason, that diagonals bisect each other. Now look at this. This is a parallelogram, this is another parallelogram. Now it AD by PM, if I can multiply and divide it by 2, I can say 2AD by 2PM. So that will become 2AD is AE and 2PM is PN. Okay. Now look at these two triangles AB PQ, AB PQ, AC PR. AC is also equal to BE because these are opposite sides of a parallelogram. So I can write AC by PR as BE by QN also. So AB by PQ is equal to BE by QN because BE is equal to AC and QN is equal to PR because they are opposite sides of a parallelogram, and it is equal to AE by PN. Right, now look at these two triangles. This triangle ABE is similar to triangle PQN. So triangle ABE is similar to triangle PQN because of their sides are proportional. AB by PQ, BE by QN, AE by PN. Because of this reason, these two triangles are similar. And if these two triangles are similar, what can you say about these angles? This angle B will be equal to this angle Q. What can you say about this angle? This angle, if this angle is alpha, what will be this angle? This angle will also be alpha. Right? So now, if this angle is equal to this angle here, what can you say about these two angles? This angle and this angle? The way we have proved triangle ABE and triangle PQN similar, we can use the same way and say that triangle ACE is similar to triangle PRN. And that way we can show that this angle will be equal to this angle here. Right? Okay. So, proving similarly, we can prove triangle ACE is similar to triangle PRN, and hence if this angle is angle beta, this angle will be beta. Okay, so angle EAC is equal to angle NPR, and I have taken these angles as angle beta. So now angle A is equal to angle P because both of these angles are alpha plus beta each. Okay, so now once I have proved that angle A is equal to angle P, AB by PQ is equal to AC by PR, it is given. Right, so we can say AB by AC is equal to PQ by PR, and angle included between these two sides is angle A, angle included between these two sides is angle P. So by side angle side similarity criterion, we can say triangle ABC is similar to triangle PQR. Okay, so this is the method that we are going to use in this question. Okay, a vertical pole of length 6 meter casts a shadow 4 meter long on the ground. So there is a vertical pole of 6 meters and shadow that it casts on the ground is 4 meter at a certain time of the day. At the same time, a tower casts a shadow 28 meter long. So there is a tower, and at the same time it casts a shadow 28 meter long. Why is it important to give at the same time? Because of the sun rays, right? So there will be at a particular time the length of shadow will be proportional, okay, but if you take different times of the day, it may not be similar, right? If let us say at 1 p.m. okay, you observe this pen, there will be a certain shadow of this pen. At 4 p.m. it will change, but at 1 p.m. this will have a certain shadow and certain other object will have a shadow as per its length. Okay, but we can compare these shadows. I'll just tell you how. Find the height of tower. So now this angle is 90 degrees and this angle is also 90 degrees. If I complete a triangle here and a triangle here, okay, will this angle be equal to this angle? Yes, because sun rays are coming in this fashion here, okay, so they will make an angle here and the same angle will be made here. Because of the same time, we are observing these two shadows at the same time, so this angle is going to be the same. So if it is alpha, it is also alpha. So these two triangles are going to be similar, hence the ratio of their sides is equal. So if I name these triangles as ABC and PQR, triangle ABC will be similar to triangle PQR, hence the ratio, let us say 6 by 4, will be equal to this ratio PQ by 28. So this will become 4 7s are 28. So PQ is 6 7s are 42 meter, right, to keep this ratio same. Alright, and it will always be true. You can take any other object also, so it will have a shadow somewhere, right? This angle will also be alpha if you are observing at the same time, and this angle being 90, this triangle will also be similar to these. So if any of these two dimensions is given, I can obtain the second one using the concept of similarity. Okay. If AD and PM are medians of triangles ABC and PQR, so there is this triangle ABC and triangle PQR. AD is median of this side BC, it bisects side BC, and PM is a median which bisects QR. And ABC is similar to triangle PQR. Okay, so if ABC is similar to PQR, what can I say about this angle and this angle? Angle B will be equal to angle Q. What can I say about these sides? AB by BC will be equal to PQ by QR. Yes, the ratio of corresponding sides. If you want to write it like this, you can write it like this also. AB by PQ is equal to BC by QR. This much is given because of this similarity, right? Why I have taken only this much information? Because I need to show that AB by PQ, is equal to AD by PM. Okay, so I will choose these two triangles, and in these two triangles, this angle is equal to this angle. Ratio of AB and PQ I know is equal to BC by QR, but BD is half of BC and QM is half of QR. So AB by PQ will be equal to BC by QR, and it means that it will also be equal to the ratio of their halves, because it doesn't change the ratio, right? Half of BC is BB half of QR is QM. So yes, AB by PQ is equal to BD by QM, and angle between them that is angle alpha, or angle B in this triangle and angle Q in this triangle, these are also equal. Hence, by side angle side similarity criterion, triangle ABD is similar to triangle PQM. Okay, and if these two triangles are similar, then this relation that AB by PQ is equal to AD by PM is true. Why? Because the corresponding sides of two similar triangles are proportional, right? Hence, proved. So this was about this exercise. I hope you have understood all the questions. We will take up some extra questions also, so that you can practice enough questions for your examination point of view. Thank you.